Hi, welcome to the Olympiad geometry. Let's continue our study. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe to the channel. So this is a problem I found from the AOPS, and I asked the person posted whether I can make video for it. He agrees with that. So let's check it out. I want to make this video just because this is a question about the Miquel's point, and as we discussed the Miquel's point, I didn't find very difficult problems actually, but this looks like a decent one. So I want to talk about this one. So remember that Miquel's point is actually about the property of the complete quadrilateral, and we will cover a lot of properties of the complete quadrilateral in the future in the geometry treasure series. So this just as a problem that actually most of the properties will be covered, but let's just continue on this one. And I will put this one in the playlist of problem from the audience. Okay, let's start. The problem set is pretty straightforward. It's saying let ABCD be a cyclic convex quadrilateral. So you should be very careful of the problem set. Here, the most important problem set is the word cyclic, right? In the most of the complete quadrilateral, we are not force the ABCD to be cyclic, right? Okay, let E to be the intersection point of AB and CD. F is the intersection point of AD and BC. ABCD has a center O and diagonals AC and BD cut at P. Prove the following. So we have several things here. The first one that circles ADE, BCE. So let me just put the figure here so it's easier for us. So the figure looks like kind of complex, just because we have so many questions here. So we have A, B, C, D, right? That's a quadrilateral. I didn't draw it fully actually. Yeah, let me just draw it here. Okay, I'll just draw it here, and the CD, I'll just connect it. Okay, we have ABCD here. That's cyclic quadrilateral, which you can see I draw the circle of it here, right? And we know that AB meets CD on EO. Let me forget about these points. Okay, these points will be used later, but not right now. So AB meets CD on E, and BC meets AD on F. Actually, let me just put it aside. We can draw it here, right? So we have the circle first, and okay, so we have A, B, C, D, E, F here, right? And we want to prove that the circle ADE, the circle BCE, circle ABF, circle DCCDF intersect at a common point, which called Miquel's point, right? Actually, this we already covered before, but let's just do it again. So assume that we have this point here, right? Assume we have this point here. And we know that we can just think of this as intersection point of circle ECB and circle FCD, right? That is perfectly fine. Right, this is a circle intersection point of the circle EBC and the circle CDF. Now we know that these 4 points are cyclic and these 4 points are cyclic, right? So we want to prove that M is also on the circle AED, which means that based on these 4 points, BEMC are cyclic and FDCM are cyclic, we want to prove that AEMD are cyclic, right? So let's connect BM here, and let's connect DM here. To prove this one, to prove AEMD are cyclic, we just need to look at this angle, this one, equals to the angle MCF equals to this one, right? And we already know that BCF are collinear, so this angle equals to this angle because BEMC are cyclic, which means the angle MDF equals to angle AEM, which means AEMD are cyclic. Similarly, we can look at this angle, the angle EBM equals to angle ECM. And because CMFD are cyclic, that means this angle, the angle ECM, equals to angle DFM, right? Which means angle EBM equals to angle DFM, which means BMFA are cyclic. Okay, so therefore, the circle EBC, circle EAD, circle FCD, circle FBA are concurrent. Okay, and now we want to prove that M is on EF and M is on OP. Precisely, M is inverse of P with respect to O, which means that we want to prove that the P point is diagonal intersection point P here, right? So basically we want to prove that PO times OM equals to R squared, right? Let me write it as R squared. R is OB or OD or OC or OA, right? And the second half, we want to prove that OM is perpendicular to EF. Okay, so let's just take it one by one here. Let me come back to use this one, so that's easier. Okay, so first thing is that we want to prove EMF are collinear, right? M is on EF, which means the EMF are collinear. We want to prove that. So look at the angle EMC. The angle EMC equals to angle ABC equals to 180, right? The angle EMC equals to angle ABC. And because ABCD are cyclic, So the angle ABC equals to 180 minus angle ADC, right? Minus this angle. And it equals to 180 minus angle, because CMFD are cyclic, so the angle ADC equals to angle CMF, which means angle EMC plus angle CMF equals to 180 degree, right? Angle EMC plus angle CMF equals to 180 degree. That means EMF are collinear. Right? And now we want to prove that OPM are collinear. So this figure is difficult to look at, but let's just use this figure. It's easier. So we want to prove that OPM are collinear. We just prove that M is on the EF. Okay, so to prove that OPM are collinear, the first thing I want to prove is that OBMD are cyclic. Right? I want to prove that OBMD are cyclic. So please follow me. I show the correct figure here. Let's use not that correct figure, which is easier to look at, right? We don't have so many lines there. Let's try to prove that OBMD are cyclic first. The angle BOD equals to twice of angle BAD, right? The angle BOD equals to twice of angle BAD. And we know that angle BME equals to angle BCE equals to angle angle BAD. Right? The angle BME, this one, equals to this one, which is this one, right? And angle DMF equals to angle DCF equals to angle BAD. And we already know that EMF are collinear, right? That means the angle EMF is 180 degree, which means angle BMD equals to 180 minus angle BME minus angle DMF equals to 180 minus twice of angle A, or angle BAD. Right, let me show it here. The angle BMD equals to 180 minus angle BME minus angle DMF. And angle BME equals to angle BAD. Angle DMF equals to angle BAD. So that's 180 minus twice of angle BAD. Which means angle BMD plus twice of angle BAD equals to 180 degree. Which is angle BMD plus angle BOD equals to 180 degree. Right? So that is saying BODM are cyclic, right? Because angle BMD plus angle BOD equals to 180 degree. Now let's try to prove another thing, that angle, again, this figure is very difficult to look at because it's not an accurate figure. Let's look at this one. So now I want to prove that OCMA are cyclic. Okay, I want to prove that we just proved OBMD are cyclic, and now I want to prove OCMA are cyclic, right? So if you look at, let me find the proper way. Okay, so if you look at angle AOC, angle AOC equals to twice of angle ABC, right? And angle CMN or CME, right? Because BCME are cyclic, right? BCME are cyclic. So angle CME, this angle, actually angle BME or BMN. Let's use BME here. The angle B. Oh wait, let me see. No, we don't need to do this. Yeah, the angle CME. Angle CME equals to angle CDF, right? Because CDFM are cyclic, so angle CME equals to angle CDF, which equals to angle BAD. Wait, no, sorry. Which equals to angle CBA, right? See here, the angle CDF. Because ABCD are cyclic, so angle CDF equals to angle CBA, right? This angle equals to this one. And if we look at the angle AMF, the angle AMF here, AMF. Now because ABMF are cyclic, so angle AMF equals to angle ABF, which is angle ABC, right? Equals to angle ABC. So CBA is angle ABC. That means angle AOC plus this is angle AOC here. The angle AOC is twice of angle ABC, which can be rewritten as angle AOC is angle CME plus angle AMF, right? That means angle AOC plus angle CMA equals to 180 degrees, right? Because angle AOC equals to angle CME plus angle AMF. So CME plus AMF plus angle CMA equals to 180 degrees. That means angle AOC plus angle CMA equals to 180 degrees, which means AOCM are cyclic. Right? Now you need to be very careful here. If you look at the circle OBMD, Okay, the circle OB, let me write it down here, OBMD. We want to check on the circle OBMD, the circle OCMA, and the circle ABCD. Okay? If you look at the circle OBMD, which is this one, and the circle OCMA, which is, I didn't draw it, but think about that. There is a circle OCMA here, right? And what is the common chord of the circle OBMD and OCMA? You can just pick the vertex, right? So OM is a common chord of OBMD and OCMA, right? That's OM. And for the circle OBMD and circle ABCD, we know that BD is a common chord of circle OBMD and ABCD, right? And for the circle OCMA and circle ABCD, we know that CA is a common chord. Common chord of OCMA and ABCD. Right. What does that mean? OM is a radical axis of the circle OBMD and circle OCMA. And BD is a radical axis of circle OBMD and circle ABCD. CA is a radical axis of the circle OCMA and circle ABCD. And basically, we are talking about three circles intersect each other, and we find the common chord or radical axis of each two, right? And if you remember the property of the radical axis, we know that these three radical axes are concurrent, which means the BD, the intersection point of BD and AC, the point P is a concurrent point of BD, AC, and OM, which means P is on OM. Okay. So for now, we just prove that M is on EF and M is on OM. P is on OM or M is on OP. Okay. Now we want to prove that OM is perpendicular to EF. So we just prove that OBMD are cyclic, and because OB equals to OD, that means angle OMB equals to angle OMD, right? And because angle OBD equals to twice of angle BAD, that make angle, see, this is twice of angle BAD. So we know that angle BMD is 180 degree. Angle BMD is 180 degree minus twice of angle BAD, right? And we already know that BO equals to OD. That means angle BMO equals to angle OMD, which means the angle BMO, this is D. Okay, the angle BMO equals to half of angle BMD equals to 90 degrees minus angle BAD, right? And if you look at the angle BME, because BMFA are cyclic, so angle BME equals to angle BAD, which means angle BMO plus angle BME, because BME equals to angle BAD, so the summation of these two angles equals to 90 degrees. So if you look at here, the angle BMO plus angle BME equals to 90 degrees, which means OM is perpendicular to EF. Okay. And by the way, here we want to also prove that M is inverse of P with respect to O, which means we want to prove that OP times OM equals to OB squared. Okay, this would be extremely easy for us now because we already know that angle BMO, because OBMD are cyclic, so angle BMO equals to angle BDO equals to angle OBD, right? Which means the triangle BOP and the triangle BOM are similar, which we can easily get this one. Okay, and for the next question, it's actually a question about the geometry transformation, and I want to leave it in the future just because in the past we didn't talk about even the basic of the geometry transformation. It's not really useful for now, and I will cover the geometry transformation. I think it will take us about more than 1 year, at least 1 year, maybe 2 or 3 years to cover fully cover this topic. It's very deep, so let's just skip this for now. And for the audience that interested in this one, please email me. I'll show you this one in the email. And now let's look at the final question. We want to prove it's actually Newton-Gauss line. It's let KLN be the midpoint of AC, BD, EF respectively, right? We have K here, it's the midpoint of AC. L here, it's a midpoint of BD, and N here, it's a midpoint of EF. And we want to prove that they are collinear. Okay, we want to prove that K, L, N are collinear. So just think about this. We have the K, L, N as a midpoint, which means we have some ratio already, right? 1:2 or 1:1 ratios here. But if you look at these AC and BD and EF, they are not mapping to a triangle, which means it's impossible to directly use Menelaus theorem. So we need to find some auxiliary lines that can help us to translate the ratios, right? So think about the K, it's a midpoint of AC, and now we can just find the midpoint of EC, which I mark here as I, and we can find the midpoint of BC, which I mark here as G, right? And also we find the midpoint of EB, which I mark here as H, right? Just because in the triangle AEC, right, you can think B is a point on side AE, right? And G is a midpoint of CB, I is a midpoint of CE, and K is midpoint of CA. That means KGI are collinear, and the line KGI is in parallel to the line ABE. Right? Similarly, just because we find in the triangle BEF, right? N is a midpoint of EF, I is a midpoint of EC, and H is a midpoint of EB. That means HIN are collinear. And line HIN is in parallel with line BCF, right? And we covered this line, we covered this line, and for this line, right? In the triangle BED, L is a midpoint of BD, G is a midpoint of BC, and H is a midpoint of BE. So HGL is in parallel with ECD. Okay, great. Now let's think about the point KLN. We can think about the triangle HIG and the KLN. Of course, we don't know whether they are collinear or not right now. We want to prove that, right? So just think this, we are trying to use the converse of the Miquel's theorem. So this is a triangle, this is a intersection line, which means we can just write down here that GK to IK times IN to HN times HP to GP, right? If this one equals to 1, if we can prove that this equals to 1, that means KLN are collinear, right? That's the converse of the Miquel's theorem. So what is GK to IK? GK to IK equals to AB to AE, right? And IN to HN equals to CF to BF, right? And HP to GP equals to ED to CD. Right, we want to prove that this one equals to 1. And we already know that this is a complete quadrilateral ABECFD, right? So if you look at the triangle EBC and the intersection line ADF, we can write down the Miquel's theorem, right? Which is BA2 EA times ED2 CD times CF to BF equals to 1, right? Because this is valid, that means this is true, right? They're the same. Therefore, KLN are collinear. Okay? So this is a question of the Miquel's point. I'm still looking for the question for the conjugate median, and please let me know if you have any good questions on the conjugate median. I didn't find very sophisticated questions here, but please let me know if you can find some good questions. I would like to make videos for it. Okay, I hope you liked this video. See you in next one. Thank you.